right, for those of you who wanted it, I'm going to go step by step through the 4-4, 4-5 quiz review for our quiz tomorrow. Step 1, or number 1, solve. So we got the cubed root of 12x equals negative 3. So the cubed root is by itself, so now we can cube both sides. And what that does is it cancels out on the left side, so we just have 12x. And negative 3 cubed, negative 3 times negative 3 times negative 3 is a negative 27. Then, of course, to get x by itself, we divide by 12, and x equals negative 2.25. So we can have a decimal. It won't be likely, but it could. All right, our literal equation, we had some issues with this. We got to solve it for s. So first, we need to get the square root by itself. So we got to get rid of that a. That's a times the square root of all that junk. So we got to divide. So it's w over a equals the square root of 3 minus s. Now our square root's by itself, so now we can square both sides. So it gives us w over a squared equals 3 minus s. As the square root and the squared cancel out. Then we subtract 3. So we have w over a squared minus 3 equals negative s. I don't care what negative s is. I want to know positive s. So really, we divide by negative 1, and all that does is flip the signs of everything. So negative, in parentheses, w over a squared, plus 3 equals s. Just undo your operations till you get the variable that you're supposed to get by itself, by itself. Number 3. Square root's by itself already, so we just square both sides. So on the left side, they just cancel out. That's the whole point. And 4 squared is 16. And we subtract 7. 3x equals 9, divide by 3, and of course x equals 3. That one's not too bad. Should be able to do that one fairly easily. Number 4. This one's a little bit more work. The square root is by itself, so now we got to square both sides. On the left side, the squared and the square root cancels out. We get 12 minus 6x. Now, x minus 2 squared, we cannot just distribute the exponent. I told us this I don't know how many times, we keep forgetting. It's really x minus 2 times x minus 2. So we have to double distribute. We get x squared minus 2x plus 4. So a grand total of x squared minus 4x when we add our like terms plus 4. Now we have an x squared, so to solve this, we're going to have to get everything equal to 0. So we'll subtract 12, and we'll add 6x. So now we got 0 on the left, because everything cancels out. We have x squared plus 2x minus 8 when we simplify the right side. So now we need to factor this. We need to do an MA table. We need two numbers that multiply to negative 8 and add up to 2. And what's nice, the coefficient of x squared is 1, so we can skip right to our parentheses once we find our numbers, which of course are 4 and negative 2. So now we have 0 equals x plus 4 times x minus 2. Now we want what numbers make x plus 4 equals 0 and x minus 2. So this will give us x equals negative 4. This will give us x equals 2. Now that's great, but we have to check for extraneous solutions. We got to make sure that both of them work. So I'm not saying we have to do this all the time or write it out, but we should probably get in the habit of doing that. So we substitute in negative 4. We have the square root of 12 plus 24. Square root of 36. And the square root of 36 is 6, which is not equal to negative 6. The negative 4 doesn't work. That's our extraneous solution. Now let's make sure that 2 works. 12 minus 6 times 2 equals 2 minus 2. That's 12 minus 12, or 0. 2 minus 2, 0. And last time I checked, 0 does equal 0, so that is our solution. So you always have to check. Number 5, our thing with the rational exponent is not by itself yet, so we can't raise it to the 4/3 yet. We need to add 10. We have x squared minus x minus 14, all to the 3/4. Those cancel out, equals, 8. Now we can raise both sides to the reciprocal of that exponent. Now remember, brackets are the same thing as parentheses. I'm just using brackets so we can see them a little bit different than the other parentheses. So we're going to raise it both sides to the 4/3 power. Now on the left, those cancel out, and we get x squared minus x minus 14. Again, that's the whole point. Now this is 8 to the 4/3 power. That's an exponent. It's not times 4/3. So we're not sure how to do that on our calculator. There it is. So 8 to the 4/3, we use a little caret key, and you can just put it in as a division. And we get 16, and that's it. So of course we have x squared, so we need to get it equal to 0, so I'll subtract 16. X squared minus x minus 30 equals 0. We got to do our MA table. We want 2 numbers that multiply to negative 30 and add up to negative 1. Really, there's a 1 there. So the 2 numbers that work are negative 6 and 5. So we got x minus 6, x plus 5 equals 0. So this tells us x equals 6. This tells us x equals negative 5. And both answers do work because they're squared, and if we plug them in, we can see that. So both are fine. And they, for the most part, will be the same when we're dealing with fractional exponents. Now on to 4-5 stuff. F plus g of x and state the domain. So again, all that is f of x plus g of x. And f of x is just x squared plus x minus 30 plus g of x, which is x minus 5. So all we're doing here is adding like terms. There is no other x squared. We got x plus x, so 2x, not x squared. And negative 30 and negative 5 is a negative 35. So when we add them, that's it. Our domain, well, there's no fractions, there's no square roots, there's nothing stopping from having all real numbers. So that's our domain. Number 7, we're subtracting now, and make sure we have g first. So it's g of x minus f of x. So again, we just substitute in. G of x is x minus 5 minus x squared plus x minus 30. So we're subtracting everything in that second set of parentheses. So distribute the negative there because we're subtracting. So it's minus x squared minus x minus a negative 30, which is plus 30. First function stays the same, and now we just add up our like terms. Well, x and negative x cancel out, but we do have a negative x squared to start. And we got negative 5 plus 30, grand total of plus 25. Our domain, same thing as the last one. There's nothing stopping us from having any number we want, so it's all real numbers. Now, things are going to change with the domain for number 8 because we have division, and we know we can't divide by 0. So f of x divided by g of x. And just kind of ignore that x and just do f divided by g. So that's x squared plus x minus 30 over x minus 5. So we got to do an MA table for the numerator. On two things that multiply to negative 30 and add up to 1. That would be 6 and negative 5. And we can skip there because our coefficient of x squared is 1. Now, before we simplify, we have to make sure we get our domain. So it's going to be all real numbers except, well, what makes the denominator equal 0? X minus 5. We don't want that to be 0. So if we add 5 to both sides, x cannot be 5. So that's our domain. Now when we simplify, we can cancel out our x minus 5s. So our answer is just the x plus 6, just chilling by itself. Moving on to number 9. H of g of 2, our composition, which we are not fans of. So first we put the 2 in the g function. So g of 2. So instead of the x, we're going to substitute in something for that variable. What are we going to substitute in? The 2. And of course, 2 minus 5 is negative 3. So now this turns into not h of g of 2, but h of negative 3, because g of 2 is negative 3. So we substitute in negative 3 to the h function. So that would be negative 3 squared plus 1. That's 9 plus 1, or 10. So if we put in a numerical value, like we're doing here, you're going to get a numerical value for your answer. If you don't, you did something wrong. Number 10, same idea. F of g of negative 1. So first, do g of negative 1. So d is our x minus 5. Now what do we subtract, or what are we substituting in? The negative 1. So we get negative 6 from that. So g of negative 1 equals negative 6. So f of g of negative 1 actually equals f of negative 6. Again, just straight up substitution. Now we'll deal with f of negative 6. The f function is something squared plus something minus 30. What's that something we're substituting in? Negative 6 for x. So it's positive 36 minus 30, or minus 6 minus 30, and all that equals to 0. So it's just a two-step problem. That's it. It's 2 substitutions. Now, obviously, 11 and 12 get a little bit more complex. So g of f of x. Well, let's try thinking of it this way. The g function is something minus 5. Well, what is that something? What are we plugging into it? We're plugging f of x, which is x squared plus x minus 30. So all we're doing is taking that and we're subtracting 5. So it's x squared plus x minus 35. So really wasn't too bad. We also could have written it as g of, and then f of x was our x squared plus x minus 30. So we plug that into the g equation, which is what we did up here. And now we have the reverse. F of g of x, same thing as what we just did, written differently, but it's the same thing. So f of g of x g of x is x minus 5. Now the f is our variable squared plus our variable minus 30. So now what are we substituting in? X minus 5. So we got to simplify this whole side here. Now, x minus 5 squared is x minus 5 times x minus 5. We got to double distribute. We get that, and we add our like terms. We get x squared minus 10x plus 25 plus x minus 5 minus 30. And now we just add up all our like terms. We only have the 1x squared. We got negative 10x and 1x, so negative 9x. And then we got 25, negative 5, and negative 30. Grand total of negative 10. And that's our quiz review. This is what's going to be on our quiz tomorrow.